Hi, this is Ms. Fitzmaurice. This video is an explanation of free response problem number 4 in your review packet. So in this problem, we have a spring. It's compressed backwards a distance x. Okay, so that's like the compression of the spring. And it's on a horizontal frictionless table. This table is a height of h above the floor, and we're compressing a mass m back. It's released and it flies a distance d until it lands on the floor. Now, the question is, if instead of compressing our spring by a distance x, we compress our spring by a distance 2x, A, will the distance in the second trial be greater? So we care about distance. And then B, we care about the time. So what I'm going to do is I'm going to give you the math. I'm going to essentially explain the answers to both of these. Then I'll give you what earned points, and then you should, in your own writing, rewrite the parts that you missed points on. So before we solve for distance, it's going to be easiest to solve for time, and we can solve for time using 1D kinematics. We can say basically, because in each case the block is leaving the table with Vy equals 0, okay, what that means is we can use our first kinematics equation to find time, right? So we can use xy equals xoy plus voyt plus 1/2 ay t squared, okay, and this is after it leaves the table. We know that xy is 0, it lands on the ground, voy is 0, and we know ay is negative g, so we have xoy, which is the height, 0 equals height, minus 1/2 gt squared. We can solve for t. So I'm going to bring 1/2 gt squared to the other side. I'm going to multiply by 2, so I have 2h. I'm going to divide by g, take the square root, and I have, in both cases, t equals root 2h over g. Okay, so I know that h is the same in both cases, so t is also the same. Alright, so the horizontal distance that it flies, what I'm really looking for is xx, and I know that xx will be equal to xox plus voxt plus 1/2 axt squared. In both cases, ax is 0 and xox is also 0. I know that my t from before is just 2h over g square root. Okay, so I have my distance d, okay, and that's my xx, is equal to vox times root 2h over g. Okay, so what that tells me is that the distance depends only on Vox. Okay, that's the speed with which our block leaves the table. Okay, now we need to be able to compare VOX in both cases. So we can use conservation of energy Okay, we have case 1 and case 2. In both cases, energy is conserved, so we have sigma E naught equals sigma E. Okay. At the beginning, I only have spring potential energy, and at the end, I only have kinetic energy. Okay. And I'm going to fill in 1/2 k delta x squared is equal to 1/2 mv squared, and this v is our VOX. So I have 1/2 k delta x squared equals 1/2 mv squared. My halves go away, and in both cases, since my equations are identical, I can solve for v. V is equal to delta x times the square root of k over m. Okay, and that's true in both cases. Okay, we know that in case 2, we have a bigger delta x. Okay, so what that means is that we have a bigger velocity, okay, which means our VOX when this thing is flying off the table is bigger, which ultimately means that our XX is bigger in case 2. So in case 2, this thing flies a larger distance horizontal. So let's talk about assigning points to this. Okay, so it doesn't matter the order that you put these in, but they have to be in a paragraph together. So you get 1 point for saying that the time is equal in both cases. Okay, you get 1 point for saying that the motion off the table can be broken up into x and y. And only y is necessary to solve for t. One point for indicating that the first kinematics equation, but you have to write it out, xy equals x at y plus v at y t plus 1/2 ay t squared can be used, and that all variables are the same between case 1 and case 2. in terms of the distance, you get 1 point for saying the horizontal distance is larger in case 2. You get 1 point for indicating that energy is conserved. And that in both cases you have US equaling kinetic energy. You get 1 point for in some way showing that VOX, okay, the speed, the block leaves the table is proportional to delta X of the spring. And then finally, you get 1 point for indicating the first kinematics equation. XX equals XOX plus VOXT plus 1/2 AXT squared can be used for your final answer.